Good morning, students. Welcome to this class. This morning, we'll be examining a topic which I call extraction of aluminum. And I want to start this class with a definition of what an ore is. An ore is a deposit of mineral which contains an element that can be obtained profitably in large quantity. In other words, every element exists in form of an ore. In other words, an ore is a deposit of mineral in a way that extraction of that mineral element from that ore will bring profit to the people involved in the extraction. If it does not make profit, then such an ore is not worthy of any investment, because if substantial amount of money is invested with the ore, what it means is that the people will run into a loss. So the ore that is worthy of this for the extraction of aluminum is called bauxite. Bauxite has a chemical formula of Al2O3.3H2O, hydrated form of aluminum oxide. This bauxite is not pure. And because it's not pure, the first process in the extraction of aluminum is to purify bauxite. When bauxite is purified, what you will obtain is called alumina. Alumina has a chemical formula of Al2O3. Al2O3 is called aluminum oxide, but the industrial name is alumina. Alumina is just as an ore, is the pure form of bauxite. So when bauxite is purified, the product is alumina. The scope of the purification of bauxite is beyond the scope of what we are learning in this class. Nevertheless, what you must know is that alumina is the product obtained when bauxite is purified in the industry. Another ore of aluminum that is worthy of note and very important for this class is known as cryolite. Cryolite is a soft ore. It's not as hard as bauxite or alumina. The formula of cryolite is Na3Al(F6). Cryolite has a number of functions, but later in the course of this class, I will highlight the function of cryolite. Before we leave this slide, I'd like you to know that the diagram on our left-hand side is a electrolytic apparatus for the extraction of aluminum in the industry. And you will see that in the structure, we have a positive charge and a negative charge. The positive charge is the anode, and then the negative charge there represent the cathode. And you could see both the cathode and the anode are made of the same electrode, carbon electrode. As you all know, that carbon electrode is one of the electrodes that we call inert electrode. They do not interfere with the cost of extraction of the element compared to what we call reactive electrode that dissolve and increase the concentration of the electrolytes. Inert electrode do not dissolve in any way at all. And in the extraction of aluminum or many reactive elements, inert electrode are often used. Another example of inert electrode is platinum. In fact, we only have those two examples of inert electrode. So in this extraction, we are making use of carbon electrode, which is an example of inert electrode, and consider the inner lining of the vessel is where we have the cathode. So the inner lining represent the cathode. The inner lining being the cathode. The reason why the inner lining is being used as the cathode is that whenever aluminum deposit, it will deposit on the surface of the cathode, which is the inner lining, and in most cases it will just drop at the bottom of the vessel, and from there can be removed and processed further into different form of iron metal. So the inner lining is suitable and is used to represent the cathode. And then we have about 4 rods there, or plates. The rod-like structure there represent the anode. And it's in another diagram, you can see it in form of 3 rods, sometimes 4, like we have here, or sometimes it will be 5. The higher the number, the faster the process of the electrolytic extraction of the metal. And that is just the explanation of the structure. But before I complete the explanation, you could also see that the in any electrolysis, there must be what I call electrolyte. The electrolyte contains the ion that is to be extracted, the desired ion to be extracted. And in this case, the desired ion is aluminum, and aluminum is present in the electrolyte. And in this electrolyte, you will see that the electrolyte contains is a mixture of 2 compounds. The first compound is aluminum oxide, and the second one is the cryolite. The aluminum oxide is very hard. When it is heated and it melts, it is then dissolved inside molten cryolite. Molten cryolite is softer than aluminum oxide. So therefore, you can see that the aluminum oxide dissolved in molten cryolite. Here you will see that molten cryolite serves as a solvent to dissolve properly aluminum oxide. Let's move on. What are the significance of the electrolyte? From the fact that the electrolyte contains the desired element or metals to be extracted, all right, we can talk of 3 significance of the electrolyte, especially the molten cryolite. The significance of the cryolite in this case is very, very important that we must know. The first significance of the cryolite, which is used as a solvent in dissolving aluminum oxide, is that the presence of cryolite increases the electrolytic conductivity of the electrolyte. Cryolite helps to increase the electrolytic conductivity of the electrolyte. And the second point over there is that the blend of cryolite helps to reduce the operating temperature of the electrolyte. What do I mean by the operating temperature? Like I told you before, aluminum oxide is not a soft compound, it's very hard. It decomposes at a very high temperature. And when it requires so much money or cost, it costs a lot, or it wastes money to trying to decompose aluminum oxide. And so when we add molten cryolite, the temperature is, or the operating temperature has been effectively reduced. So let us talk about, let's quickly highlight the functions now of the cryolite and the mixture of electrolytes. Number 1, it serves as a solvent. Number 2, it helps in reducing the operating temperature of the extraction. Number 3, it helps to increase the electrical conductivity of the electrolyte. And then we want to again talk about the electrode reaction. We have the anode reaction, and we also have the cathode reaction. Here you will see that the anode reaction, let me talk about the anode itself. The anode is the point where oxidation reaction is carried out. When I mean oxidation reaction, I mean process whereby electrons are lost. So as I was saying, that in the electrode compartment where we have the anode reaction. That the anode reaction is the compartment where the anode is the compartment where oxidation reaction occur. And what I mean by oxidation reaction is that it involves loss of electrons. And so the anode is positive, it will be attracted to the negative ion. And the negative ion here is oxide ion. What is the formula of oxide ion? The formula of oxide ion is O2 minus. O2 minus. So O2 minus will undergo oxidation reaction. And that the O2 minus is 2 minus means that there are two moles of electrons there. 2 moles of electron. 2 minus. And because O itself does not exist on its own, so we require 2 O2 minus. If 1 O2 minus will give me 2 moles of electron, then 2 O2 minus will give me 4 moles of electron. And then in the process, for each O2 minus will give me 1 O. So 2 O2 minus will give me O2. The equivalent bond between 2 atoms of oxygen will occur to form oxygen molecule or oxygen gas. So briefly, that is the equation that occurs at the anode. This equation is very, very important for you to understand that in the oxidation reaction, we have the product and the electron on the right-hand side. The product is oxygen and the electron is 4 moles of electrons. Both of them will be at the right-hand side. The only one that will be at the left-hand side is the oxide ion, and the equation of the balance 2O then O2. 2 times 2 at -4. We have -4 on the right-hand side and -4 on the left-hand side. Whenever you write a reaction like this, you must balance it. So it is balanced in this way now. And it's very, very important that this reaction at the anode has a major consequence. The major consequence is that the reaction produces oxygen gas. And we know that oxygen gas is responsible for combustion of anything. So the electrodes are often being combusted by the oxygen produced. The anodes are set on fire or are combusted or used up or get burned because of the oxygen produced at the anode. So the anode has to be replaced regularly so that whenever it is being burned, because when it is being burned, it's render the whole process ineffective or slow. So the anode has to be what? To be replaced regularly. So new anode will be added regularly to ensure that efficiency of the reaction is enhanced regularly. That is the consequence of the oxygen produced at the anode. Now we go to the cathode. And the cathode reaction, the ion of interest is Al3 plus. Al3 plus. The Al3 plus will accept 3 moles of electron. So on the left-hand side, Al3 plus accepting 3 moles of electron, 3E minus to give Al atom. So the atom, aluminum atom deposited at the bottom of the vessel, where we have the cathode, the inner lining of the cathode. So it sits at the bottom of the inner lining of the vessel. And you can see in the diagram molten aluminum, and there's an opening there, an entrance where it can be removed. That entrance is very, very important. That entrance is where the aluminum produced is eventually removed. That is the entrance there in the diagram there, and that's about that. And then I quickly want to talk about the overall reaction. The overall reaction is very important. Look at the overall reaction. We have 6O2 minus plus 4Al3 plus minus to give 3O2 gas and 4 mole of aluminum. In that one, for each complete reaction, we are going to have 3 moles of oxygen produced and 4 moles of aluminum atom produced. Very, very important. Altogether, we have 7 moles in for a complete reaction, 3 moles of oxygen and 4 moles of aluminium atom. And altogether, now how many moles of electron are consumed when one complete reaction takes place? For us to do that one, we have to do a little bit of balancing or balancing to get the overall equation. How can we get this overall equation? In order for us to get the overall equation, we simply have to consider the electron that we have used. Over here, you will see that we have used 4 moles of electrons, and also in here we have used 3 moles of electrons. In other words, for us to get the overall number of electrons used here, we have to multiply. Let's call this one equation 1, and then we also call this one equation 2. We have to exchange the mole of electron in order to balance it. So equation 1, we multiply it by the 3 moles of electron, while equation 2, we multiply by 4 moles of electron. When that is done, what we are going to get is that equation 1 will now have 12 moles of electron, because 4 times 3 will be 12, while equation 2 will be having as well 12 moles of electrons. And these 12 moles of electrons, they are on both sides, they are on different sides. We have the equation 1, 12 moles of electron is on right hand side, while 12 moles of electrons on the left hand side. So, and they are both negative, left and right. So it can cancel. So the 12 moles of electrons used for us to have a complete one equation of reaction. So 12 moles of electrons are produced. And that's about that. In order for us to now write the overall equation, since we have counted the electron, then we must complete the multiplication. So let's see the using 3 on the top. So 3 times 2O2, we're going to have 6O2 minus. While 4 times Al3 plus, 4 times Al3 plus, will give me 4Al3 plus, and they are both on the left hand side. No other species is on the left hand side. So we have 6O2 minus plus 4Al3 plus to give. What do we have in the equation? 3 times O2, we're going to have 3O2, while 4 times Al, we're going to have 4Al, 4Al. That is very important. So we have done some multiplication there, and then so to give the overall equation, and you must practice this regularly in order for you to be able to do this. And I believe that with constant practice, it will be a lot easier for you to understand. And that is how to get the first equation. And moving on there, you will see we're talking about the uses of aluminium. What are the uses of aluminium over there? A number of uses can be said, but the first one is talking about that aluminium is used in the manufacture of the body of aeroplane. And this use is based on the fact that aluminium is a light metal. And an aeroplane that will be flying in the air does not require a heavy metal. So aluminum is perfectly suitable because it is light. It has light density, light weight, and it's shining. And using aluminum to construct the body of a plane is suitable for such purpose because it does not require a heavy metal. The second use, as you can see in the diagram, is that used in the manufacture of cooking utensils, such as the pot itself, the cooking pot. The reason why aluminum is used for manufacturing of cooking utensils is because it is a very good conductor of heat. And then the third use of aluminum that is used in the manufacture of storage cans and tins. you will see all this baby food. The can of baby food is made, the inner surface is made of, the inner surface where the food is kept is made of aluminum, because aluminum oxide is insoluble in water and it's very hard. So you won't get to be scratched and to form an impurity to the food kept, because it is insoluble. It won't dissolve, and it is not scratch, and it's also it does not scratch. It also resists corrosion. Okay, it does not rust, does not corrode easily. So three basic properties of aluminum: does not corrode easily, it does not dissolve water, and it is very hard. It will not easily be scratched. And so the food stored in aluminum can is safe for eating, or for is safe, no contamination whatsoever. And then the fourth and fifth use would be, it is also used in the wrapping of food. The same property applies when it is used in wrapping of food. It is attractive, it's shining, and so when our food is wrapped in it, it looks beautiful. Also, in the industry, in the world of paint, aluminum dust is embedded in paint. It is used, it's one of the reactant that is used in the manufacture of paint. Here we have an image here where we have electrical wire. Electrical wire are made of two major metals. It is either we use copper or aluminum. Copper is cheaper, so copper is mostly being used. But when we talk about excellent conductivity, aluminum is a better conductor than copper. So aluminum is used, if you don't want to consider the cost, aluminum is a better metal for the manufacture of electric wires and cable, because it is a better conductor. It has 3 moles of electron that will carry current throughout the wire. And so aluminum is a perfect conductor compared to copper. Nevertheless, copper is also a perfect conductor and is good enough. The seventh use of aluminum and its compounds that are used in the manufacture of the ring of automobile. Ring, you can see this one in the image is very shiny. So aluminum ore, such as the combination of aluminum is used to make magnesium. Magnesium is an alum of aluminum and the magnesium with better fundamental property. Is better than aluminum. So magnesium is a mixture of aluminum and magnesium, and it's better than either magnesium or aluminum. And many people want to have this kind of a ring called alloy ring in their watch, in their car. Alloy ring from the word alloy. It's an alloy ring made of different elements put together. That's very, very important. And to end this class today, we're talking about doing some classwork to enrich your knowledge. And so I'm going to give you a few minutes. I'm going to give you like 7 minutes to complete this classwork. We have 3 questions there, and I'll give you just 7 minutes to complete that. And also, moving on, when you're done with that, you also come down here for another classwork where you are to describe the electrode reaction, and also describe why the anode, or explain why the anode electrode has to be replaced regularly during the extraction of aluminum. State and explain 2 uses of aluminum and its ore. And finally, you will proceed to your IGCSE past questions, where you will open to March 20, paper 4.2 and question 2, and you complete the question there for 19 marks. Deadline is 28th of August. With that, I hope, do I have any questions? All right, no question. Therefore, I want to thank you for taking time to come to my class today. I see you next class. God bless you. Thank you very much. I see you next class.